Hello everybody. Today we're going to actually finish up our Unit 2 and talk about fitting models to curved relationships, because not everything is best represented with a least squares regression line. So a quadratic model is a model in the form of y hat is equal to ax squared plus bx plus c. And you guys should all know what a quadratic model looks like. You've all taken Algebra 2 at this point. The graph of the quadratic model is a parabola. So the two scatter plot below actually are showing the relationship between passing yards and age for 32 quarterbacks in the 2010 NFL season, along with their quadratic model. Now, as you guys can see, there's not really a line that can just be drawn through these either way because they're all touching different points. What does model this even better is a parabola that comes up and down, which can actually be shown in this part right here. In fact, the equation for this is y hat is equal to negative 13.65x squared plus 835.5x minus 9,258. So if we wanted to actually find a point on here, we could actually find residuals, like this is actually Brett Favre's point. But I'm going to show you guys how to do this all in the calculator. So we're actually going to switch over to our calculator view to do this next problem here. So here are all the steps. We're actually going to be doing all these steps when we are going over the example. So example number 17. Baseball pitchers try to prevent hitters from reaching base. One way to measure the effectiveness of a pitcher is WHIP, which is calculated by the formula WHIP is equal to walks plus hits over innings pitched. That's where the WHIP comes from. The table shows the age and WHIP for all 17 years of Bob Gibson's MLB Hall of Fame career. What we're going to do is we're going to calculate the quadratic model for these data using age as the explanatory variable. So this would be our x, this would be our y. So again, we're going to switch over to our calculator view to figure this one out. So we're now on our calculator, we're in our list, and we're going to put age in L1, and we're going to put WHIP in L2. So what we're going to do here is I'm probably going to fast forward just a little bit as I put all the things in. No one wants to hear me say all these numbers out loud. Okay, so here we go. 23, 4. Once you have everything done, I always suggest quickly going back through your list because this is a lot of numbers and just making sure that everything matches up, because I would hate for you guys to make a tiny little mistake somewhere in here and then not get the right answer. So just go quickly back up your list, make sure everything matches. Okay, triple check here will definitely help you later down the line. Okay. So once you have this, what you're going to do is you're going to press Stat. You're going to go over to Calculate, okay, and you're going to choose Quadratic Regression, which is right here in number 5. So once you're here, your x-list is in L1, your y-list is in L2, and you're going to do two things. First of all, remember that it's always important to store your regression equation, because if you look at part B of this example, we're actually going to be calculating the regression, quadratic regression, and the scatter plot. So it's good to do that here. So remember to do that, you're going to press VARS, which stands for variables. Go over to Y variables, function Y1. If we store this in Y1, it will also graph the curve. So when we go to calculate this, we're going here. Okay, so now we have A, B, C, and R squared. So that means it's going to be Y hat is equal to A. So I'm going to round the nearest, let's say 4 decimal places here. 3 decimal places because they have their decimal places rounded to 3. So we're going to have A is 0.009 because we rounded x squared. And then we have minus 0.558x. And then our C is plus 9.811. So here is our quadratic model for this equation. In B, it's telling us to sketch the scatter plot along with the quadratic model on the calculator. So we're going to go back to the calculator. So we're back to the calculator, and what we're going to do is we're going to go to second stat plot. We're going to make sure our stat plot is on, and it's actually here on residual, so I might want to make sure that L2 is in there. To make sure that L2 is in there, you would press second, and then if you go down here to 2, you see that little L2 there, you would make sure that the L2 is in there. Great. And you would want to graph it. Now remember that in our Y1, we have our quadratic model. So now the scatter plot and the quadratic model are going to graph when we press graph. Okay, so it's still working. Okay, so this doesn't really give us a good look, so what we're going to do is we're going to press zoom 9, and then here is our scatter plot with our regression model. Great. So what we're going to do is, now that we graphed our regression model, quadratic model, we are going to go back here to our other one, and we are going to calculate and interpret the residual observation when Bob was 24 years old. So when Bob was 24 years old, his actual Y was 1.673. His actual Y was 1.673. So what we're going to do is we are going to take our regression model, our quadratic model. We have Y is equal to 0.009, but in for X, we're going to put 24. And then, so then we have minus 0.55824, and then plus 9.811. And you're going to put this into the calculator, and you're going to get 1.603. So now that we know his predicted Y, we can find the residual, which is what we're looking for. And we know that the residual is Y minus Y hat, the actual minus the predicted. Now the actual, again, was over here. It's 1.673, and our predicted was 1.603. So if you subtract that, you should be getting 0.07. So what does this mean? Because we need to interpret this. This means that Bob's WHIP when he was 24 years old was 0.07 greater than predicted by the quadratic model with x equal to age. So this is how you would solve a quadratic model problem, but it's not just quadratic models that we can look at. We can also look at exponential models. So an exponential model is a model in the form of y hat is equal to a times b to the x power, where b is greater than 0. So b is always greater than 0. Now if b is greater than 1, the graph will show exponential growth. It'll go up. But if b is between 0 and 1, the graph will actually show exponential decay. If you look at the two graphs below, we can see clear exponential growth. And this is actually a little background on this. Gordon Moore was one of the founders of Intel Corporation and predicted in 1965 that the number of transistors on an integrated circuit chip would double every 18 months. This is Moore's law, one way to measure the revolution in computing. So in this figure is a scatter plot showing the number of transistors for Intel microprocessors and the number of years since 1970. Since the year 1970, number of transistors in billions. If Moore's prediction is correct, then exponential model should be a good model for this data. So you can see here on the left that we have something that doesn't look quite like a line, right? We couldn't really draw a line through all this data. But if we have this smooth curve that's going up showing exponential growth. So this one is also, we're able to do this right on the calculator. So we're actually going to jump to example number 18 because you guys will always have this, okay, in your notes just in case you forget. You also have the video. So in example number 18, do healthier countries tend to be wealthier countries? A random sample of 20 countries was obtained from gapminder.org. Gapminder is a great little place to look for this kind of data if this is your type of thing. The income per person in US dollars and the life expectancy at birth in years were recorded. So what we're going to do is we're going to calculate an exponential model for these data using life expectancy as the explanatory variable. So life expectancy is our explanatory variable, which means income is our response variable. I don't know why that just went down. Okay, it's doing its own thing. So what we're going to do is we're going to switch back to the calculator, and we're going to do that now. So we're back to our calculator. What we're going to do is we're going to go back to our lists. We're going to go into Edit, and I'm going to clear both these lists just by pressing clear. Do not press delete because you'll delete your list. Press enter, go up to L1, press clear. Okay, so now we have our clear list, and I'm going to put in life expectancy in my L1, and I can put income in my L2. So I'm going to do that as quick as I can. We probably will speed through it now. Okay, and don't forget that it's actually really important that you take a few minutes just to go back over what you have, just to make sure that you didn't make a mistake. Looking through. Okay, so now we have all of the pieces in here. So what we're going to do is we're going to go back to calculate. So we have to go to stat, go over to calculate, and then if you look down here, we have our exponential regression. I believe that's at 0. Yep, so here we go at 0. So we're going to go to our exponential regression. So we have our x list in L1. Let's focus this. Okay, we have our x list in L1. We have our y list in L2. We're going to store the regression equation again in y1. You go to variables, go over to y variables. We're going to put y1 in there. So now when we graph our scatter plot, it will also graph our exponential model. So we're going to calculate, give it a second, and here we go. We have our exponential regression. So we have y hat is equal to, so we have 5.4161 times 1.1076, we forgot our little point there, to the x power. So that's our regression model. We're going to go back to the calculator to show our scatter plot. Okay, let me just make sure. Okay, great. So if we go to y1 here, we can see that our exponential model was put in. So if we go to second stat plot, we now have our stat plot on. Just make sure it's on. It's a good thing to just kind of like look through it, make sure everything's all good. Then you're going to press graph. So give it a couple of seconds. It needs to catch up. These are much bigger numbers than our other one. So that's why we're not seeing anything. There we go. So we can't see anything. To get a better look, we're going to press zoom 9. And there we go. So here is our scatter plot. Look at it go. Excellent. Okay, so what we're going to do is we are now going to calculate and interpret the residual for Mexico. So if you look at our graph, Mexico is here. Okay, so our actual was 11,684. But what we're going to do is we're going to put that into our calculator. So we have 5.4161 times 1.1067 to the x power. In this case, our x was life expectancy at 77. So we're going to raise this to the 77th power in your calculator. So once you put that in your calculator, you're going to get $14,164. So to find our residual, we're going to do y minus y hat. So our actual was 11,684. Our predicted was 14,164. So our residual, after we put into the calculator, is negative $2,480. So this means that the annual income per person for Mexico, income per person in Mexico was $2,480 less than predicted by the exponential model with x equaling life expectancy. Okay. So we just learned how to graph a quadratic and exponential model. You can always use your calculator for that. And if you guys notice, we are not going anywhere because we are done with the section and we are done with the unit. As always, I'll be in the Google Meet, or you can chat with me through GoGuardian. Email me any questions. I'm happy to help. I hope you have a fantastic day.